Hello, in this short video I'm going to solve the following A+ level problem. A ball is projected horizontally from the top of a tower of height h with an initial velocity v0. It hits the inclined plane, which makes an angle of 30 degrees with the horizontal perpendicularly. What is the initial speed of the ball? Pause the video at this point and give it a try. The first thing to solve the problem is to set up our coordinate system. So let us take this ground level, the x-axis, and let us take this one, the y-axis. And of course, I want to take this one as the origin of my coordinate system. The ball is initially at the top of the tower, so this means that the initial x-coordinate x0 of the ball is 0 because it is somewhere on the y-axis. And the initial y-coordinate of the ball, y0, is equal to h, the height of the tower. But the initial velocity of the particle in the x direction, which I call it vx0, is exactly equal to the magnitude of the velocity vector v0. From now on, I just simply write it v0. And the initial velocity in the y direction is 0 because the particle is projected horizontally according to the problem. So what does it mean? It means on the horizontal direction the particle moves uniformly with constant speed v0, and the vertical motion of the particle is just a free fall under the influence of gravity. So this means that the equations of motion for x and y directions are following the standard formulas of uniform motion and motion with constant acceleration in the vertical direction. So this means that x as a function of time will be v0 t, and y as a function of time becomes minus 1 over 2 gt squared plus the initial y coordinate, which in this case is capital H. Okay. If I want to find the equation of the trajectory of the motion, I should eliminate t from these two equations. So I simply take this equation and find t, which is x divided by v0, and then I plug this here instead of t. Then I will get a relation between y and x, which is the equation of this parabola, the trajectory of the motion. So then it means that y becomes equal to minus 1 over 2 g x v0 squared plus capital H, which I simplified. The simple algebra will give me minus g over 2 v0 squared x squared plus capital H. Okay, but now let us understand the equation of this line. Because this angle is 30, so this means that the slope of this line is tangent of 30, and because it passes through the origin, the y-intercept of this line is just 0. And we already know that tangent of 30 degrees is 1 over square root of 3. So the equation of this line simply becomes 1 over square root of 3 x. Okay, so let me take this point of intersection and I call it t. Let me assume that the coordinates of this intersection point are alpha and beta. Okay, according to the problem, if I draw the tangent line to the parabola, to this dashed line, at the point t, this line, which is the tangent to the parabola, intersect the inclined line at a right angle triangle. At a right angle, 90 degrees angle. They are perpendicular. So this means that the slope of this green line multiplied by the slope of this line should be minus 1. This is a very famous result from Math 2C. Okay, the k-value of this line is just 1 over square root of 3. But what is the k-value of this green line? This is tangent to the parabola. So if I want to find the slope of the tangent line, I have to differentiate my function and then replace x in the derivative with the x coordinate of the point of tangency, in this case alpha. So let us go to this function differentiated with respect to x, which is very simple. Y prime becomes minus g over 2v naught squared, are just constant. The derivative of x squared is 2x, and the derivative of capital H, because it's constant, is 0. So it's simply 2 and 2 are now simplified here, 2 and 2, and then y prime becomes equal to minus g over v naught squared x. But what is the k value of the tangent? So if you don't mind, let me call this t, the line t. So the k value of the tangent now becomes minus g over v naught squared alpha. So this is the k value of the tangent line. And if you don't mind, let me also call this line L. What is the k value of L? The k value of L, as we calculated before, is just 1 over the square root of 3. And now, because these two lines are supposed to be perpendicular, so it means that KL multiplied by KT should be minus 1. So this means that 1 over square root of 3 multiplied by minus g over v naught squared alpha is minus 1. From here, simply I can find alpha. First of all, this minus sign and that minus sign are gone, and then g alpha becomes equal to square root of 3 v naught squared, and it means that alpha is equal to square root of 3 v naught squared divided by g. This is alpha. The relation between alpha, the x coordinate of the point of intersection, with the initial speed v naught. Okay, but now you know that this point lies on the line. So this means that the coordinates of this point will satisfy the equation of the line. So it means that if I replace y with beta and x with alpha, this will hold. So one relation that I have is just simply beta is equal to 1 over square root of 3 alpha. Okay? So that is also one relation. Another relation is that this point also lies on the parabola. So the coordinates of the point will satisfy the equation of the parabola that you see here. So it means that when I replace y with beta and x with alpha, the equality will hold. So I will do that. So beta is equal to minus g over 2v naught squared alpha squared plus h. Okay? Now what I will do, instead of this beta, I put this expression, so it becomes 1 over square root of 3 alpha equals to minus g over 2v naught squared, but instead of alpha, so let me write alpha squared plus h. And in the next stage, because my target is not to find alpha, if you look here, if I solve this equation, of course it's a quadratic equation alpha, it will give me alpha. But my target is to find v naught. So why not? Let me just eliminate alpha in favor of v naught. So it means that I will use this relation. So instead of this alpha, I put this expression, and instead of this alpha squared, I will put this expression to power 2. And more or less I am done. So let us do this algebra. It becomes 1 over square root of 3 alpha is the square root of 3 v naught squared over g equals to minus g over 2 v naught squared. Alpha squared becomes 3 v naught to power 4 divided by g squared and plus h. So let us do some simplifications here. This is square root of 3 and that square root of 3 are gone. This g from here and one of these g's are gone. V squared here and two of them are gone. V naught squared is left. So let me rewrite what I have. On the left I have v naught squared over g. On the right I will have minus 3 halves v naught squared over g plus h. And now what I will do, I will move this to the other side, so it becomes and I factor v naught squared over g. So I will have 1 plus 3 over 2 v naught squared over g is equal to h. But if I simplify this, it is just 5 over 2. So it becomes 5 over 2 v naught squared over g is equal to h. My goal is to find v naught squared. So v naught squared becomes 2g h over 5. And then finally, v naught is the square root of this expression. This is the v naught. Okay? So this means that this answer is correct. I hope this video was useful for you. Until the next video, be safe and goodbye. Thank you.